In this video, I'm going to talk about some factors connected to prenatal as well as newborn development. And there's going to be several terms I go over. They are going to be heredity, environment, interaction between heredity and environment, epigenetics, epigenetic marks, which are connected to epigenetics, and then more connected to the newborn and early years is the enriched environment and critical periods. So first, heredity. Heredity is the genetic transfer of characteristics from parents to offspring. And that is in contrast to the environment, which is every external influence. So when we talk about the gene or environment, is it nature, nurture? What we're talking about is heredity versus environment. The genetic transfer of characteristics from parent to offspring, the genes that are passed down, that's heredity, that's the nature. And then nurture is every external influence, whether it's prenatal or later in life. So one thing that can confuse people is the prenatal environmental influences. So for example, in the next chapter, one thing we'll talk about is sexual orientation and factors that contribute to what your sexual orientation will be. And one of them is the prenatal environment, specifically connected to, if you're male, how many older brothers, biological brothers you have. So the more male fetuses a woman carries, the greater the chance her youngest sons will be gay. The way this works out is when a woman carries a male fetus, it's more foreign to her body than when she carries a female fetus, because there's these Y chromosomes connected to males, since males are XY and women are XX. So all of a sudden her body's being exposed to these Y chromosomes that her body has never seen before. She doesn't have any. And her body produces antibodies to it. And so every time after that her body carries another male fetus, it produces more and more antibodies. And so each future fetus male fetus has an increased chance of having a homosexual orientation. This isn't a huge increase. It's just 3 to 7%. It's not that large, but it is a significant change. But you're born that way. You come out of the womb with that predisposition now, but it's not heredity, it's environment, because it was your prenatal environment, the antibodies you were exposed to inside your mother's womb, that contributed to that. So that would be an environmental factor, not a heredity factor, even though it's something you have from birth. Another example of that would be the fact that if your mother gets the flu while pregnant, you have a significantly higher chance of being schizophrenic. It's a 7-fold increase if your mother gets the flu in the first trimester, which is one reason you should get your flu shot if you're pregnant. And again, you are born with that predisposition to schizophrenia now, but it is not a nature thing. It's not a genetic thing. It's not heredity. It was the flu virus affecting your development in utero. So that would be considered an environmental factor, a nurture factor, even though it's something that happened prior to your birth. So when we talk about this nature-nurture thing, it's not, did it happen before you were born or after? It is it explicitly from the X or the Y chromosome from your parent, or is it anything after conception? And oftentimes when we talk about this, it's really not one or the other. It is an interaction. That's the interplay that occurs when the effect of one factor depends on another. Like nature versus nurture. It's not really nature versus nurture. It's nature and nurture. So an example of this, where it's not really one or the other, would be like schizophrenia. That could be a good example. So partly it is nature, partly it is genetic. If one of your parents has schizophrenia, you have a significantly higher chance of being schizophrenic. Your genes do play a part. But again, the environment plays a part as well. Things like the prenatal environment, but also your actual environment later on, your physical environment. Oftentimes, someone has their first schizophrenic episode in their early 20s when they are under pressure, when there is stress. It's that interaction of their genetic predisposition with the stress in their environments. And when we talk about how the environment influences gene expression, turning genes on or off, that type of interaction is what we call epigenetics. So the stress in your environment that turns on that schizophrenic gene would be epigenetics. Specifically, the stress is an epigenetic mark. The epigenetic mark are the molecules that trigger or block genetic expression, like stress hormones, diet, drugs, things of that nature. Another example would be in my family, we have a genetic predisposition to diabetes. It's shocking that more people don't have it in my family because we have this genetic predisposition. We have these genes from both sides that lead to diabetes. And so if you look, say, at me and my brother, I know about this genetic predisposition, and so I am fairly careful with diet, making sure I exercise because I don't want to turn on that gene. I don't want to develop diabetes. My brother had a very different lifestyle and didn't take as much care with his diet. And so he ended up dying from diabetes in his 20s. So even though we had the same genetic predisposition to quick onset of diabetes, we had two very different outcomes. So when people talk about genetic predispositions, it's not always one or the other. It is a combination of factors. It's this epigenetics, gene and environment interacting with each other a lot of the time. And that's the same thing a lot with the psychological disorders like schizophrenia, depression, bipolar, ones where there's a strong genetic component to it. It doesn't mean you're 100% going to get it. There's a lot of environmental factors that make it more or less likely as well. Now, after the kid is born, growing up, there's a couple of things that affect how you turn out. One is enriched environments. Enriched environments are important. This does not mean you need to go and buy Baby Einstein for your 6-month-old to watch. That's not going to be an enriched environment. An enriched environment basically means it's not a horrible environment. For example, they did a study with 2 groups of rats. And one group of rats was put into a boring cage. There wasn't anything in it. It was just food and water, and they were stuck in that cage for 60 days. The other group of rats were put into a fun cage. They had toys, they were able to interact with each other, and they spent 60 days in that cage. So half the rats in a boring environment, half of the rats in an enriched environment. After 60 days, they killed the rats and looked at their brains. And the rats that had been in this enriched environment, their brains were 7 to 10% heavier. They had more neurons, they had more dendrites specifically, they had more myelin around their axons. They had better brains because of that environment. So your environment plays a role in your development. It also matters what time period you are in at the time. So critical periods are periods early in life when exposure to certain stimuli is needed for proper development. For example, one of the dumbest things we do in this country is not start second languages until middle school or high school. By that point, there's no way you're going to speak another language like a native speaker. You've got to start it young, when the critical period is. If you are not learning another language young, like 7 or sooner, you're never going to be able to understand the sounds of that language and say them in a way that you sound like a native speaker. Another example that is slightly more extreme is cataracts. So I'm sure everyone's heard of cataracts when older people have cloudy lenses. You can be born with this as well. You can be born with a cataracts. And if you have one at birth, you need to have it removed within the first year of life. If you do not have that cataracts removed in the first year of life, if you have the surgery done, say when you're 5, it doesn't matter anymore. You're going to be blind forever in that eye. There is no way you will ever see again, because the neurons connected to that eye that go to the part of your brain connected to vision will be gone, and you cannot get them back at that point. The critical period for vision has passed. So you have these certain time periods in which you can have proper development. For like vision, it's that first year. Language, it's the first, well, you start to lose ability to understand at 10 months, but really by 7. Even attachment, if you've ever heard of kids who are adopted from like Eastern European orphanages who have trouble connecting to their adoptive parents, that's because they missed a critical period in attachment. You need to attach to a caregiver in your first 6 months of life, or it's possible you'll never have the ability to attach to someone in a loving way. So different types of development have different time periods, different critical periods, but you really need to have these occur in a healthy way, or you'll never have proper development in that area. And that is it for prenatal and newborn development.